Hi everyone, this is Panos from Hack the Box, and we are going to go over one of last year's easy web challenges. And this was one of my favorite challenges, and we are going to go over how a pen tester would see a challenge like this, how a pen tester can benefit from something like this, and some of the general pen testing process guidelines. Mm, why am I doing this presentation is, okay, a couple of things for me. I studied computer science, right? I did both my bachelor's and my master's in the Athens University of Economics and Business. I started being a CTF player with some guys that I learned from university. And that led me to landing my first job, being a penetration tester. And I was doing that for 4 years before joining Hack the Box. Right now, I'm working at the community CTF of Hack the Box, like Cyber Apocalypse, University CTF, all this stuff. And I wanted to show how a pen tester can benefit from all of this and how all these challenges are realistic, okay? So why would a pen tester would join a CTF once he already has a job or whatever? So it's a great learning opportunity. Good CTFs always provide you with new attacks and modern stuff and stuff that you haven't seen before. And it's very difficult to study everything by your own. Sometimes this gamified aspect will help you to get to your studies more quickly, like do your job and do the studying that it requires. Second of all, it's the hands-on practice. Reading about an attack is great. I like to read like write-ups and disclosures of vulnerabilities, but it's not the same as doing it. So you can either try to set up an environment. That's a great. You will learn probably more things actually by setting up the vulnerability yourself and the whole server and the infrastructure. But the reality is this will take a lot of time. And the CTFs are a great opportunity to do this without having to do everything, just the attack part. Second of all, if you are part of a pen testing team, you probably all of you like hacking. That's why you gather all this knowledge, right? So it's nice for teams to bond over doing something they like. They can do it on their work time or whatever, and they can play together and they can form alliances, see each other, the strength of each other. And I think it's a great team building opportunity overall. So when we're doing like a pen test, there are various kinds. So what you will most usually find is like the three different kinds of it that exist. So the first one is the black box penetration testing. That is, no information is required, like you know your client and that's pretty much it. Maybe you know if it is like something very specific that they want to test, but you have no information and nothing provided whatsoever. So the pros of this is like, this is the most realistic, that it looks like an attack, right? And, but of course you will miss a lot of stuff probably because you will not find everything if it's big enough, the organization, and it's time consuming because you have to spend a lot of time of the assessment, try to discover new things and try to understand how things like this work. So at the other end of the spectrum is the white box penetration test. That's the most thorough of all the methods. So you are provided everything, and this includes the code. So this can be time consuming, but this you can be sure that that you will find the most things, right? But since if you are not an in-house team, it's not so usual for people to just give you their code and their backend infrastructure to external providers of pentest. So as an external pen tester, the most usual stuff that you will do is what we call a gray box penetration testing. That means some of the information is provided, like your client will tell you some things that you will need to know in order to do a more thorough test. That can mean that the endpoints, that can mean the logic behind the application to see if you can bypass this logic. That can be, usually they give you accounts. For example, if you have a web application that have like a user role and an administrator role, there is a chance that you will get credentials for both these roles, right? And this is kind of a balance between the two, and this is actually, I think, the most often, at least in my experience. So let's start to talk about things that we see in CTFs, login screens. Okay, so if you recognize this picture or a picture like this, it's if you try to Google about SQL injection, this is the image that most usually gets brought up, right? Like the example that you have, that you can use SQLi to bypass a login screen. That is nice, and this is nice for a very easy challenge in a CTF. But the reality is, I don't think there is that much SQL injection in login forms. I think in my career, I have never found anything, and I have never heard anyone finding anything. Then the reality is like web developers know about this, so they will probably do a correct job in this. And what you can find in login screens, the second thought is like brute forcing, but the reality is if you do not know the username or the password, try to brute force both. It can be time consuming at first and very complex, and it will take forever. And all these attempts will trigger all the different alarms that a SOC might have, like the traffic would be too much from a single IP and they will be notified of your attack. So one common thing that you find a lot is what we call a username enumeration. That means if I try to type the name admin, I will get a password, an error message saying that the password I provided for admin is wrong. But if I use my name Panos, for example, and there is not a Panos user, I will get that the user Panos does not exist. That makes it easier, the brute forcing part. First of all, because you can brute force all the usernames and you can find the usernames. And once you know for sure that the usernames are what they are, you can try to brute force the password after that point. Then there is about what we're talking about severity. Okay, how important, not important, how dangerous vulnerabilities. In this example, you have the same vulnerability, like a cross-site scripting vulnerability. But in the one example, you get just some code execution that you cannot use for many things. And in the second part, you can see that the code that you run has access to some things like the document cookie value, which can be can be really critical if as we will see at the next slides. So before going to the workshop, I would like to discuss some attacks that we're going to see there. First of all, is the cross-site scripting attacks. If you're doing web penetration tests, you will meet a lot of cross-site scripting attacks in your career, right? So what it is exactly, it's like a JavaScript injection in a page. So usually it's when there is an input from a user, that user can provide JavaScript code. What the web application should do is treat the user input and display it as text. A lot of times they are not go through the sanitization process, and the result is the user input gets treated like code. And that means this code will run to the next user that will visit the page. XSS cannot harm usually the backend of an application because, as we know, JavaScript runs on the client side, so runs in the browser of whoever visits a site. But there are still some serious consequences of this. And you can find this in like, this can be like a blog post, like comments, can be fields that are vulnerable to XSS, like usernames at certain cases, stuff like that. After that is the session hijack. So the way HTTP works is stateless. You have a server and you request things and it gives you things back. It has no way to recognize you any other way than cookies. And it's what we call a stateless protocol. You do not go through states, but you provide information, and according to that, you get answers. So the only way for a web application to recognize a user is through his session cookie. So you can do a test yourself. You can try to log into Facebook, for example, and press F12 if you're using like Firefox. I think it's the same in Chrome. And delete the cookie for Facebook and try reload the page, and you will be directed back to the login screen. And you can also copy this value, paste it to a new browser, and try reload the page while logged out, and you will see that you will be logged in again as the user of this cookie. So what a session hijack attack is, an attacker finds a way to get this cookie of another user, sets it on their browser or whatever tool they use, and they have the access of that user. XSS is one of the ways that somebody could perform a session hijack. So, okay, this is not that hard, but it may be difficult to explain. There is this attack on the workshop, and probably you will be able to understand this attack more there. So what is an insecure direct object reference? I will use the term IDOR, as everybody does. It's much shorter, right? Much easier. So what an IDOR is the application trusts the user's input to dictate what a user can request. And probably this does not make a lot of sense, but if you take this image that I took for a WASP, for example, I have the citation in this side, but I'm hiding it, I realize now. And for example, if you are somewhere that you can access documents like a Google Drive, it's like, imagine if Google Drive only trusted everything you say, so it would bring back every document file that you requested, and just trusted that you would not try to request something that you shouldn't have access for. You will understand more, I think, from the workshop part. And these are actually quite common. I used to find a lot of IDORs, and IDORs usually are part of bug bounty programs because it's not easily found by scanners. I think they are not found by scanners at all. They're usually manual work that requires and somebody to understand the way an application works. All of the stuff that I said already can be found in the Academy. You can try to see these 3 modules. If somebody has completed these 3 modules, the following workshop should be easy for them unless they fall into a rabbit hole. So now I'm going to move to my other screen, my Parrot VM, and try to solve the last year's challenge. And I will hide my face so you can see all of my screen. There it is. Let's go. So if you have never visited the CTF platform, this is how a CTF looks inside, right? You have all the names of the challenges. And if you haven't spawned the challenge, you will have an option saying spawn the Docker. And right now, I have spawned the challenge. This is the IP of it. If you click on it, it gets copied on your clipboard, so you can just paste it in a new window. Okay, we get a hint by the name that is called support. And also, we can see that this is some form of a ticketing system. We can try to see if it works. I will just type something random here. And try to send it. We get a message saying that it sends the ticket. So this creates a ticket. And we get a message that an admin will review the ticket. That could be interesting. That means that you have a user interacting with your information. Okay, before going any deeper, as a penetration tester, what I would do is I would do like a quick directory brute forcing attack to try to find the different endpoints of a web application. Right now, I have run a quick scan on a previous instance. If you see the IP is different, but I did it before. It's the same. It would be the same if I do the same now. So the possible endpoints is the admin endpoints. We see the code is 302. We get redirected, so we do not have access to this. There is a login screen. There is a logout endpoint. There is settings, static tickets. We cannot access anything from this. except the login screen. So maybe we should try to go there. Let's see, before trying anything else. So let's see if we can guess it, if the credentials are like admin, and let's see if there is username enumeration. Maybe we can brute force it. I will use admin. That's a correct message. This is what it should tell you, that you enter either a username or a password wrong. You can also try different things here, like password, for example. But you will not find everything because you're not supposed to. Okay, I mean in this CTF challenge. So let's go back to the other thing that we have access to. Okay, maybe we can try to do an XSS attack. So the standard payload that everybody uses for an XSS attack, it's like probably you have seen this. It's the alert 1 or alert XSS. You can try to send it, but the problem is even if this gets executed, it will have zero impact for us, right? If we want to solve the challenge. So maybe we can try to get the cookies of the administrator, or the person that will see this request. So maybe we want an XSS payload that does that. So there is a great GitHub repo called Payloads of the Things. I think almost all Pentesters use this repo. It has very interesting things. And if you go here, you will see that it even has the theory. For example, if you try to see the cross-site scripting session, it even has the theory and the 3 different types: the reflected type, the stored XSS type, and the DOM-based XSS type. Since this is a ticketing system, this is more like a stored XSS attack that we're going to do. And the first option is exactly what we hoped it would be. It's a data grabber, so we can use whichever of these we want. I will try to get this one now. I just copy paste it. So we need the server to make the request to. Let's go over the payload first. So what does it do? It says to the JavaScript, to the browser, load an image, and the source of this image is our localhost plus the document cookie. So if we have like a host, we will get a request, a GET request, try to find the cookie.php question mark and the document cookie. So you would probably, if you're familiar with HTTP, you would probably be using something like simple HTTP server to do this, or set up like a listener or whatever. But the problem with this is, in this challenge, it doesn't require, and all challenges do not require to use a VPN. And you are not in the same network. So if you want to hit your IP, you would want to fix your NAT, not settings on your router, and that's not the best choice. There are other choices. One of these choices is something called webhook.site, and provides users with temporary links that they can use. And this is the one that it provides for us right now. I would just copy it and replace the localhost with this. And try to see if this attack works. I think that's correct. Let's try to send it. Let's see if we got anything back. It doesn't seem like it, so probably I did a mistake at some point. Let's see what error I have done. Everything seems correct, I think. Let's try, maybe this is the error. What was it? Let's see if this fixes it. Yes, that was the error. So just to go over what my error was, is by providing 2 slashes, I was redirecting it somewhere else. And I will leave this part in the video because it's nice to know the troubleshooting process. So this is the value of the key, of the cookie, and the name of the cookie is session. So let's try to set this and try to visit one of the pages that we know exist. If you're using Firefox, you will have to go to the storage. This is the web server that you want to set the cookie to, the one that the challenge is. There's nothing now, we will create one. We will call it session, as we saw that the name is. And we will just paste the value. Is this the value, the correct one? I think it is. We're gonna hit enter, it will get saved, and let's try to load the admin page. Do you remember this guy here? This is our previous XSS, the alert one. So, okay, just click OK. And we see here, like, there are a couple of messages. This is our first ticket that we submitted. This is the alert one. And all this, if you inspect the code, you will see that there are the payloads that we tried before. Also, if you go back to the webhook site, like, a new user visited it, so there is a new hit. Of course, the same cookie because we just copied the previous one in our attack. Okay, so in a real-world scenario, that would be a great place to find valuable information. Let's see what the messages are. The one says vault whatever number requires maintenance. Okay, we cannot use this. And then there is, I have lost my RFID for the vault. My vault serial is whatever. Okay, we cannot use this. Let's see, what other information do we have? We have the name of the user we are logged in as. We are logged in as moderator. And there is a new page called settings. We have seen it also in the Dirtbuster, in the Dirt part before. So this seems to be a password reset page. It doesn't require the old password. So you just have to type a password correct 2 times and hopefully it will get reset. So Let's try to set test as a password. That in itself is a vulnerability, right? A web application shouldn't allow users to have such easily guessable passwords. Okay, we get a message saying that this is correct, but I would like to also see how this looks, how everything looks actually. So I will try to get all this through a proxy and try to see the HTTP request that we do. I have already set it up mine. Let's turn on the intercept and let's try to intercept this request. I will just hit update again. And there it is. So not many info in the headers. You get the session cookie, you get the new password value, and you get the user ID. So this is a hint of an IDOR, an insecure direct object reference. So I will send this to the repeater. And let's see the response to this request. Okay, we get a message saying that the password was changed successfully, as we saw. So this does not look secure because if I had to guess, just by seeing this, it means all the user IDs will be simple numbers, probably in a row. So I would try, for example, 101. The user doesn't exist. So, for example, that would be the first part to protect from the IDOR attack is like if the user ID was something looking like this, for example. This is not easily brute forceable. The other thing is the application should correlate the user ID with the cookie. So we have a hint that maybe this is not happening. So what I would do normal now is I would send this to the intruder. And I would just clear all this and try to attack this value. So how you do it, it's like you add this thing that I do not know how is it called. And you go to payloads and you say numeric value numbers and you can just say start from 1, go to 99999 and try to find all the values. Already I have done this and I know the correct value. So if you go and try the value 1, you would see a message saying that the password for admin changed successfully. So hopefully the username will also be admin and this would be successful. So let's try going back to the login page. Let's drop the intercept and we will need to log out. And let's go to the login again. Okay, let's see if our attack worked. Let's hope the name is admin. And let's try test value. Okay, don't want to save it. And there it is. And there is the flag. You can submit it. You can copy this. Let's also show this part. Okay, my machine is stuck. I won't show this part, but just copy this and paste it here. And there you go. You got the flag. So that was it. I hope you understand it. I hope you will have a great time tomorrow. I hope I'll see you tomorrow. And yes, that was it. Goodbye, everyone.